Today we will be talking about our room architecture, local database, how we can handle the databases in our mobile applications. First, in this particular video, I will be talking about our theoretical part, and then in the second video, I will give you the demonstration how we can practically create an database and how we can implement that in our mobile applications. So the room database or the databases in our applications, mobile applications, we are going to use our room architecture, which has been introduced by the Android systems in 2017. So what is a room? Before that, the introduction of the room architecture, we have that SQLite. SQLite is again an database engine which is has specifically designed for the mobile phones, and we have the same kind of way to access that SQLite. We have to write the queries, we have to create that connections, and the what you can say that the theoretical way, the classical way to access the database in any kind of application, whether it is a desktop application, whether it is a online application or the web application. The same has been introduced in the mobile applications as well. But later on, they adopted a architecture which is more convenient to program, more easy to program, and so the room is an abstraction layer over the SQLite, that is a database engine for the mobile applications. It's allow the fluent database access. It means that you don't need to worry much about that. You will see in the later half of that later part of the video that how we can without writing any complex queries we can access the database, and using only the programming concepts. So that's fluent database access is provided via this room architecture or room framework. So the cache relevant pieces of information, but the point is why we need that room architecture. For example, we have some applications which is actually taking some informations, data, maybe news, maybe what you can say that the order informations from the internet, and then showing all those information in our mobile applications. But without the internet, this could happen that you don't have the internet access at some time, and that news application will ask you that sorry, I can't serve you. So this is not a good experience, user experience. The reason is that maybe whenever that particular person has the internet access and he opened that particular specific news application, that news application may have downloaded 60 70 newses inside the mobile. So maybe that person has only studied 10 15 newses, the remaining newses has not been studied yet. And then again that particular user again open that particular specific news application, but unfortunately at that time he does not have the internet connection. So how that particular application is going to serve the user without the network connection, when the main purpose, the main data flow is that particular application is going to connect with the news server and fetch the latest news from the server, but unfortunately the internet connection is not there at that time. So what it can do, the news which has already been downloaded, already had been accessed from the news server, they are within that particular specific mobile. The application has an architecture like this. So if the internet is there, it will try to fetch the latest news and show it in the mobile application. If the internet is not there, then it will try to use the previous information which the application has fetched from the server, and it will try to serve those news which already inside the mobile and show those news to the user. So this is the way that without the latest information, the information which are a little bit older, still that particular application can serve the user without the internet connection. So this is where our uh, database system will help us. Without the network connection, app can provide, still can provide some contents for the from the local database. Change is synced to server when the application is back online. It means that the user can see the latest information, latest news whenever he is again connected with the internet. So Room takes care of these concerns for you. So if we have implemented, we have designed our architecture of the mobile application in such a way that I have explained you that if the internet is there, it will fetch the information from the server. If the internet is not there, it will serve the user from our local database. So in this way, the Room takes care of all these such concerns for us. So the first thing is we have to add the dependencies. As you know that we have different type of libraries. If we look at in the C sharp, we need to import some packages. We need to include some packages within our Android project or within our application. So similarly, Room is a dependency. Room is a library which is not by default there. So we have to add that particular specific dependency. And as I told you earlier, that we have Android libraries and we have Android X libraries. Android libraries are older, and Android X libraries, which has been designed by the Android systems or Android operating system, Android team, they are the new one. So of course, because we are studying the now the technology, so we try to stick to the latest technologies or latest libraries instead of the older libraries. So the latest library is AndroidX.room. And how we can add it, we need to click on that particular specific Gradle build.gradle file, that is an application module. When you open that particular file, you need to add these following lines inside this particular specific dependency tag. So under the dependency, you define, first we are defining a Room version. I mean, we are defining just a variable Room version is equal to 2.1.0, and then we are saying that implementation, it is a runtime dependency of the Room. And then we have annotation processor, that is the Room compiler, which is going to compile a lot of things for us. I will explain you later that what it is going to do for us. So we have Room runtime, and then we also have the Room compiler. So these two dependencies, and then if you look at that, we have used that particular Room version variable that we have defined here. So if later on, maybe 2.1.1, that is the new version came in, you just need to change that particular information here, and it will automatically add those dependencies with the latest or with the more latest version inside our project. So we don't need to change at the multiple places. We just need to change 2.1.1, and it will automatically include those latest libraries for the Room runtime and the Room compiler. So these are the dependencies that we need to add within our build.gradle file. And once you have added that particular specific lines, you will see that this is an what you can say that in the Android Studio, our build.gradle file is open. So under the dependencies, we have added these the what you can say that those dependencies. So as soon as you change that particular build.gradle file, it will show you the sync now. Sync now mean that you need to download, you need to access those files from the Android software development kit and included those libraries inside our application. So when you click on that, it will automatically add those things, and then later on we can use those dependencies within our programming environment when we are designing the data model and so on. So this is the first part. So we need to add dependencies in our build.gradle file, and once we have changed that particular Gradle file, we need to sync that particular specific Gradle file or the project so that these dependencies are being included inside our project. So the first thing is, because we are talking about a database, so we have different components. The first component is the database. Database is an class, simple Java class, we can say that Java class with annotated. We have the annotations, and these are actually coming from this particular Android compiler and a boiled Android runtime. Okay, so Android compiler and runtime, these annotation are coming from these libraries. They will give some directives to our compiler what type, I mean, we define a class, so how this will be considered by the room architecture. If we have no at the rate of database, it will be considered as a simple class, not a class related to our room architecture or room framework. So we need to annotate. I mean, once you will we will have the complete example, then it will be much more clear that what you mean by this at the rate of database. So the more important thing about this class, that database class, is that it should be an abstract class and it should extend a room database. It means that the class that we are defining in our Java code, that should be abstract class and it should extend the room database. It must include a list of entities associated with the database. And what is entities? I will just explain you all in the next few slides that what do you mean by the entities. Entities, to be understood in a simple way, how many tables are there in our database? Maybe one, maybe two, maybe three, maybe four. So if we have multiple entities or one entity, we need to list down when we are annotating that particular specific class with the add the rate of database. How we are going to do it, I will show you in shortly. Has abstract method with zero argument. It must have, first thing, it is an abstract class and this child class of the room database. It must include the entities that are representing the tables in the database, and it must have an abstract method with zero argument that will return me an object that is annotated with the at the rate of DAO. And if you look at that, you can click on that particular at the rate of DAO. It will take you towards the documentation of that specific annotation. And similarly, if we talk about a database, you can click on that. It will take you to the room database documentation, room database documentation. So you can, they are the clickable um, what you can say, that they are the URLs where you can access the documentation of these concepts. The second thing is again database get instance of the database. So we need to have two different way to create the database. One is the room.database builder, which take three arguments. Number one is the context, and normally this particular context is the application context. The mobile application that you are developing, the context of that application is provided here as a context. And the class, so that is actually representing the class, the abstract class that you are defining as a database annotated with the database. You are need to provide that name here, name.class class. So you need to provide the name of that particular specific class, that this particular class is actually where we have defined the settings of our database. And then the last argument, the last parameter of this particular room.database builder is the name. It means the name of the database that you want to create. So this is the one way database. It will create a database within your mobile application inside the SQLite database engine, using this context, using that particular database class definition and the name that you have provided. And the second method is room in memory database builder. It means that we are not creating a specific database which is permanent. This particular specific, if we are creating a database using the in-memory database builder, then this database is only available as soon or as long that particular specific application is running in a mobile, in my mobile application. Maybe we as a user kill that application, stop that application. It means that it will go out of the memory. When it will go out of the memory, it will automatically delete that particular specific database. Or the Android system, because we have limited memory, it decide that it, because this particular specific application has not been used by the user for a long time, and the Android operating system need to release some memory, so it may delete that particular or may remove that particular application from the memory. It means it is going to kill that application. So again, in that situation, that database will disappear. we will not have no information at all. So these are the two different ways. If in the first way, this particular database is a permanent database which is always be there whether the application is running or not running. Anytime you run that application, you can access that particular specific database using that particular name. On the other hand, the second method, that database is only available within the RAM, within the memory, and whenever your application is going out of the memory, it will also delete that particular specific database. So these are the two different ways to build the database. How we are going to do that, I will show you in when we talk about the concrete example. The second component is the entity. So it is again a simple Java class that represents a table within the database. Entity, it means one database we are talking, one table in our database that we are talking about, contains the method used for accessing the database. Hmm? uh, Entity is there, and then we have DAO, data access object. So data access object is something which help us to access, how we can access. For example, we want to insert a new record, we want to read some information from the database, we want to update some information in the database, we want to delete some information in the database. So all those kind of methods, how the what you can say that the methods, the way that we are going to access our database, they have been defined in the data access object, and that is also need to be mentioned whenever we are creating that particular specific database class, where we are defining that database class. We need to tell that DAO, what is the DAO, and that database object is going to return me that particular DAO objects, and we always use that DAO object, data access object, to access that particular database. When we will talk about the concrete example, it will be much more clear. So this is an architecture. We have the room database, we also have the data access objects, and then we also have the entities. And if you look at that, entities are the Java classes. Data access objects are can be an abstract class. They can also can be an interface, where we have only mentioned those simple method definitions, or the method headers have been defined. And then we have the room database, which is actually using the DAO, we can read the information or write the information, read the information from the database and write the information in the database using that DAO. And the rest of application, the entities we can directly access. We can also access directly the data access object within our application, but to access the room database, we always go through the DAO that has been provided when we create that particular specific database, that has been provided to us based on the definition that we have given here. So we are going to use that DAO object to access, write the information in the database, or to read the information out of the database, or change the information in the database. So first thing is first, whenever we are trying to implement all those things, we start with defining our data model. We start with the entities. Okay, the first thing is we need to define the entities. We need to define those tables. And if we look at that particular specific on the right top corner, you can see that I have provided a link where you can go and look at the documentation of the @entity annotation. That annotation is again coming from the room libraries. So it's a Java class which is annotated with the @entity, and it represents one table inside our database. So this is an example. So we have, for example, we are defining a public class, a student, and then we have defined some private int SID, private string first name, private string last name, private date of birth. So these are the values, or the column names, the columns that we have defined. SID is a column, first name is a column, last name is a column, date of birth is a column. And we have annotated @date of entity just above our public class student, where we are starting our class definition. Just above that we have annotated @date of entity. We can have, we can simply say that @date of entity, and we don't need to provide that parentheses information. It is fine. But what will happen if we don't provide that table name is equal to student inside the parentheses? We just only write @date of entity. So then what will happen, it will take this class name, and this table name within our database will be exactly the same as the class name. But as one particular specific class object represent one student, but inside a table we have multiple entries with multiple records for multiple students. So we want that that particular table name within our database should be students, not student. So for that, why for that particular specific, to achieve that specific task or the goal, what we are saying that at the date of entity we start the parentheses and then we say table name is equal to students. So now what will happen? The table name within our database will be students, not the student, that is the name of the class. The same thing if we talk about the SID, that is student ID we're talking about. I'm saying that again, I'm annotating that specific field, that specific column with a specific annotation, and we are saying that at the rate of primary key, and you know that what does a primary key in a database mean. This is a column which help us to uniquely identify one record inside our database table. And same, we have string first name. We are applying the principles and recommendations for defining the for selecting the variable name here when we write the first name. But maybe we don't want, maybe we don't like this as a column name inside our specific database. So if we want to override, if we don't provide that at the rate of column info names equal to first name, we can simply say that private int sid private string first name without that particular specific line, no, without specific line, that at the rate of column info names equal to first name. Then what will happen, the name of the variable, that will become automatically the name of the column inside our database. But if we don't want to do if we want to override that particular specific default behavior, then we can simply say that at the item column info, the name of that particular column is first underscore name instead of first, which is smaller, and then name capital. Okay, the same thing is for the last name and the date of birth. So we have defined 1 2 3 4 different columns within our table that is will be our students, but inside our Java code we will be representing that particular each and every record as a student class object, not as students. So this is the first thing about the entity. Primary key we have talked about. We can specifically designate a specific column as a primary key that will be a unique and not null value. We have to provide the value, and this should be unique for each and every record inside it. If we have a simple primary key, we can define it like this. Only one column is the primary key, so we can define right above that particular specific column name, we can annotate it with add the date of primary key. But what if we have the composite primary key? In the case of the composite primary key, we cannot define that with our columns. We have to define it at the entity level, or we can say that at the table level, where we have defined our table name. So we can put a comma after the table name, specification and definition, and then we can say that primary keys. Now we are talking about primary keys, and then we give the names of the columns or the names of the variables which we want to consider as a primary key. For example, first name and last name combined together, they become the composite primary key. So this is how we can define a simple primary key with the column, we annotate it with the primary key. On the other hand, if we have the composite primary key, when you define at the tables level, and then we define it like this. We can also the other thing that we can do here, we can auto generate a primary key, because sometimes it is difficult to take care of this. So we can auto generate all those student IDs. So we can say that at the rate of primary key auto generate is equal to true. So it will automatically generate that particular specific ID. It will start with 1 2 3 4 5 6, automatically increment with the previous one. So that's, and again, another way to uniquely identify those SIDs. So this is about the primary key when we are defining the entity. Then we have the column info. I have already explained you what do you mean by the column info. If you want to override the default column name, that is the name of the variable within our entity class. So if we want to override that default behavior, then you can use the column info and change that particular column name in our database. We can also have the index and uniqueness properties, which we can define. So index certain fields to speed up your queries. Just give you an example. For example, if you have a student name which has a specific username as well, we have the student ID, that's a primary key, but maybe we also want to search the student based on their first name, based on their last name, based on their mobile number, based on their date of birth. Then we have to create the indexes for those specific columns so that it will index those things automatically, that database, and then it will help us to quickly identify or quickly find out those information from our tables. Remember that if the table is small with small number of entries, maybe 100, maybe 1000, 2000, 3000, it will not make no sense at all. It will make no difference to create the index or don't create the index. But if we have like 100,000 records in one table, then definitely these indices will help us to find those information quickly and more efficiently. So if we have a very large amount of data in our tables, then definitely these indices will help us. So we have the indices property within the add date of entity. Again, the index properties and the uniqueness properties we are going to define and the add the date of entity, or you can say that at the table level, not within the columns. So indices property within the annotation, add the date of entity, and we also have the uniqueness property that we can define. How we can do it? Let's see. So we are saying that add the date of entity table name is equal to student. We put a comma because we are defining a second setting for that particular specific table. So we say that indices, and if we have only one index, then we can simply say that indices is equal to add the date of index. But here we are trying to define multiple. So look at that, this particular specific part is the first index and the second index is the last name. So we are defining two index, so that's why we are putting these curly braces. And then the curly braces, we have two index, add the date of index, we are giving the name, index mobile number, we are providing a specific name for that specific index. Okay, just like we are giving some object a name. Okay, so we have the value mobile number, and then we have a unique is equal to true. It means that mobile number in this particular specific table will be have a unique value. No two students can have the same mobile number. So that's what we are trying to explain it here. We are applying certain constraints on that particular specific mobile number column information. And then we have defined the second index, that is the value on the last name. So it means that not only the student ID, that is already a primary key, and by default all the database engines define the index for the primary key. Okay, so to find out those informations quickly, we are defining two more indices in our table of the students. One is on the mobile number and the second one is on the last name. Last name cannot be unique. The reason is that maybe we have multiple students which can have the same last name. Okay, but in terms of the mobile number, we are saying that each and every student must have his unique mobile number. So this is how we can define the indices. The relationship, as you know that we have different type of relationship that exist in our databases. So it's the same thing we can implement in our room framework as well. So relationship between objects, SQLite is a relational database. It support those relations that you have seen in the database management systems before in your database courses. So the foreign key constraint between two entities we can define using the add the date of foreign key annotation, and again properties of the foreign keys. So again, because this is a foreign key, that's a relationship between two tables, we are going to define it at the table level or inside our add the date of entity annotation, just like we have defined our indices. So this is an example. We are saying the add the date of entity, inside the add the date of entity we are saying that foreign keys, and we normally define that particular specific foreign keys. We are saying that add the rate of foreign key entity is equal to student.class. Which entity? We are talking about, we are in the course class, so course is related to the student, number one thing. And then we are saying that parent columns, it means that we are talking about a column name which is exist inside our student.class, which is SID. And then we have the child name, which is we have defined in this particular course class, that is the student ID. So it means that we cannot have a course name and course ID without that particular specific student ID exist inside our student class. You will feel that it's an absurd way to do the things, but you can say that this is a many to many relationship between the course and the students. Many students can study many courses, or maybe one student can study many courses, and similarly one course being can be studied by the many students. So right now we are defining one particular specific coding. We cannot have a course. If we try to define this particular, try to understand that foreign key relationship, we are simply saying that we cannot have a course and course ID and course name unless and until there is a student who in my student class or the students table which is studying that particular specific course. May not sound interesting, but yes, that is what we have defined in this particular specific example. So in this way we can define the parent and child relationship. The course is a child, student class is a parent. In the parent class we have the SID column, which is the parent column, and in the column child table we have the student underscore ID, which is a child column. Remember, the meaning is that the student ID here in this course table cannot have any value which does not exist inside the student table. So this is how we can define our relationship between the tables. When we talk about the concrete example, it will become more clear. And the other thing is we have the nested objects. For example, the address. Address is again further subdivided, like street address, state, city, postcode, these kind of information. So if we want that this particular specific address, street, state, city, and postcode are become the informations inside our student table, then we can simply say that inside our student table we can simply say that add the date of embedded. We are not defining the simple primitive data types like string or the integer or the float, but we are defining an entry of another object class, which is a simple Java class which has different informations within it: street, state, city, and postcode, and public address. So now what will happen inside our students table? We will have the address as a column, and in that column we have street address, state address, city address, city, and the postcode information in that particular one specific column. So that will have our all the informations, and then it will be combined together automatically. So this is how we can have the nested objects within our entity, within our database entities. And then once we have defined our complete database design, for example, we have the student, what we are trying to achieve, that I will show you in the demonstration. We have a students table, we have a courses table, and then we also have the enrollments table. So because as I have explained you, the course and the students, they have many to many relationship. Many courses can be studied by many students, and many students can study many courses. So that particular specific relationship is a many to many. And in the practical realities, in the professional environment, even in the simple environment, we don't have we break down these many to many relationship in one to many and many to one relationship. Okay, so To break that particular specific relationship, many to many relationship between the course and the students, we are introducing the enrollments. So what we can are saying that the one course can have multiple enrollments, one to many relationship. Similarly, one student can have multiple enrollments, again one to many relationship. And so this enrollments table help us to decompose that many to many relationship which exist between the students and the courses. So that's why we have three tables with one to many and many to one relationships between each other. So that is our database model. So once we have defined that specific model, then we need to define our data access object. First thing is we need to define the entities. We have all those relationship, indices, column informations, all those information has been set. That complete database design has been designed. Then on that particular specific database, we are trying to define our data access objects. Again, these are the methods, abstract class, or to our abstract class to the methods, abstract class to database, either an interface or an abstract class. Normally we have that particular specific database data access object as an interface. But if in some cases we want to define certain specific properties within that particular specific DAO, we also want to implement a few methods inside that DAO object. So then we can make it an abstract class, because it can have some abstract methods which has not been defined, which has not been implemented in that class. Some methods and some properties has been given over there, but so in very few cases, in a very specific specialized situations, we have that particular specific. Normally it is an interface, and we are going to stick that particular normal case and interface. And maybe later on we will see later on in the course that we will see that how we can define abstract class as a DAO object, and then what is the purpose of that. So if it is an abstract class, it can optionally have a constructor that takes a room database as its only parameter. We can define something, we can implement all those things. So this is how we can define our DAO. We are saying that public interface, we are giving the name of that particular specific interface, and it is annotated with on just above that definition, it is annotated as a add the date of DAO. And then we can define the query. Query means that we are trying to read some information, extract some information from the database. We have add the date of insert, we have add the date of delete, we have add the date of update. So what are those? Let me explain you. So first thing is add the date of insert, not interest, add the date of insert. It means that we want to insert some information, we want to insert some records inside our database. So room generates an implementation. What do you mean by this? You know that we have the room compiler which is going to compile that particular specific DAO. So we are only going to provide this information, add the date of insert, void, it means it does not return me anything, insert one student, that is the name of the method, and then we are providing the student object as an input, as a parameter to this particular method. This method, we have defined only the header of that particular specific method, which is going to insert one student record inside our students table. But we are not going to provide any kind of implementation, how we are going to connect with the database, how we are going to write that insert query and so on. That is automatically generated by the room architecture or the room framework. So that's why we have included that room dash compiler, which is going to compile this particular specific, add the date of insert annotation, and the header add the definition of that header information of that particular specific table, and it will implement that particular specific table automatically inside our project, and then we can simply use that thing. So we are not going to implement that particular specific project, we are just going to define that header. We can also have instead of the no return value, we can, this particular insert operation can return a long value. And what it is going to represent, it is represent the row ID that has been added, because we are inserting the new record. For example, the SID is auto generated, so it will return me the student ID of that particular specific record that has been inserted inside the database. So if we are inserting one student, it can return me one long value. If we are inserting multiple, maybe we can provide an array of students here, and those all the students in that particular specific array are inserted inside our database. So in that case, it is going to return me a array of long values. All the student records which has been inserted, all of them has a specific unique ID, and all of those IDs will be returned as a long array to us. The same thing is, you can say that list long or the long array. This is a simple primitive data type. This is a long object data type which has been defined in the Java. We can use that, so we can specify any of these four return types for our insert operation. If you want to see more information, you can click on that particular specific more details and the documentation link, and you will have more information about add the date of insert annotation and about the database accessing inside our using our room framework. On If you click on that more information, it will give you more details about how we can access the database inside our mobile application. Again, here we are defining that on conflict. It means we want to insert a new record, but maybe that specific student ID already exists. By then what will happen, what it will do, the default behavior is, because this particular specific SID and it is a primary key, it should be unique, it will abort, it will not insert the new record. But what we are trying to do here, we are saying that on conflict, if there is a conflict, that conflict can be like this student ID already exists, so we are trying to insert a record for the existing student ID. But we are saying that on conflict strategy dot replace, it means that the new record that we are trying to enter inside this one replace the previous one. So that is not the normal behavior, that is the overridden behavior that we have overridden. And similarly, we can have multiple students, student 1, student 2. It will insert two student values inside, two student records inside our students table. Here we are saying that maybe we can provide two, maybe 1, 3, 4, 5, 6, 7, many students we can provide. I mean, how many students values we provide, it will automatically insert all the values, all the student records inside our database. Similarly, we have the update. Update mean it will update these existing records inside our table, and this is how we can uh, provide that particular specific definition of the method. So we have the add the date of update, on conflict replace the existing values, and then void update all students. So we have multiple students we can update, we need to provide the multiple students objects as a parameter to this method. And similarly, we can have this particular any update operation, can you return an integer value. Integer value mean the number of rows that has been updated. If we have only one student, it will return me one. The reason is that we are updating one specific record inside our table. If we have two tables, then two students values, then it will return me the two as a update if it is updated successfully. Okay, so the update methods can return one integer value as an optional. We can have a void instead of receiving that value, we don't want to. If we want to, we can specify that return type as an integer. Similarly, we have a delete. We want to delete some specific records from our tables. Again, all those methods has to be annotated with the add the date of delete, and this is how we are providing 1, 2, or 3, or 4 many students objects. All of those student records, if they exist inside our table, they will be deleted. And similarly, we can return one int value. It means that how many records has been deleted from that particular specific table. It will return me that number as a integer value as a return type to these methods. So delete methods can return one integer value. If we want to receive them, we can specify, instead of void, we can specify int. So The last part about the DAO is the add rate of query annotation. The main annotation used in the DAO, we can read and write operations. Here we have to write the queries. We can write the query. So we can normally we use added of query to read the information, but of course because we are writing the query, we can write any type of query. Maybe we can write an insert query, maybe we can write a delete query, maybe we can write a update query. So that query can be anything, but definitely we are going to perform as only a read operation. But yes, we can, using the add editor of query annotation, we can do the multiple complex operations which are not simple insert, update or delete on our so verified by the compiler. The room compiler is going to verify that particular specific query. What happen in our normal routines, normal way of accessing the tables where we are writing the query, those queries are the strings. Here again, the queries are strings, but they are not checked at the compile time. When you try to run those queries on the database, and then it will give return you the runtime errors or the exceptions, and sometimes the messages are which are coming from the database, they are not very much clear, and we are unable to understand why that particular specific problem exists inside our query and why it is not being accessed. Or so there are a lot of issues that to resolve those particular specific problems in the classical way of accessing the database. But in the room framework, this particular add the rate of query, we are writing the query in our code as a string, but it is checked at a compile time. It means if there is some error inside the query, before your program can be compiled into the executable form, it is going to give you the error messages. There is something wrong with your query, so you need to fix those issues before you can build your project and compile your project and run your project. So that's one plus point here. We can check those queries, even they are the string types, but we can check those queries that they are valid or not. So we can get the feedback from our room compiler. So these are the some examples. For example, we are saying that select a static from students. So we are saying that all the records from the students table we want to read. This particular specific query is going to be executed on the table, and it will return us a list of the students. So if we look at that, the return type list, and it is a list of students object, and here we have said load all. It means read all students. You can, these are the name of the method, you can select whatever you want. And then we also have a second example in which we're talking about add edit of query, select a static from students. We are saying that we want to select all the records, all the columns from the students table, where in for each record the student ID is equal to this, or in this particular specific. So we are saying that all the student IDs which are present in this integer array, we select if they exist in that particular student table, it will return me that list of students. If we have only one student which exists over there, then this will be a list, but list of only one student. If there does not exist any student ID in that students table, then it will return me a list of students, but and it is an empty string, empty list. So you can simply say that list dot size. If size is 0, it means there is nothing has been returned by the uh, database when we execute the specific query. Okay, this is again third example, another example of the query, add the date of query. We say select a static from students where the first name like this. It means the first name is equal to the parameter, the first name, the first parameter that of that string type, first name. So the first name within column value is equal to the first parameter, that is the first name, and the last name, and last name is like the second last name parameter. So we are saying that we are finding by name. The method name is find by name. We are providing two values here as a parameter, that is the first name and last name. So we check in our database in the students table, if the first column value and the last column value are exactly the same as the parameter that we have provided, it will return me the student's record. If maybe we have multiple students with the same name and last name, it will return me the multiple student objects or student records, and all of them will be received inside a list of the students type, return type. So this is how we can define. First of all, we are defining our entities. The second thing, we are defining our DAO. We also have the older dependencies. These are the older dependencies in the Android libraries. So if you look at Android.arch and persistence room runtime and the compiler, we also have the testing. So if you want to use the older libraries, of course you can do using these kind of dependencies, but that's not our right the purpose right now. So the okay, so let me quickly we have defined, we will build this particular specific application in which we will check that user login. If there is no, in the beginning there will be no user, there will be no information, so we need to register. When we do the registration, we need to provide the first name, last name, username and all those information. And then once we have login, we can see our record, and then we can see, we will build that particular demonstration later on. But right now let me show you that we have the students table in which we are developing those students indices, last name, first name. We also have the student, and then we have all the different type of values. The second step is we need to create the DAO. We are defining the DAO. The third step is again we are defining that DAO with the insert, update students with the course enrollment and everything, and the database class. So if you look at our discussion till now, we have defined the entities, that is our data model. We have defined our DAO, data access object, that is the interface, how we are going to access those information from our tables. And then this third step, the final step, is defining that particular specific database class. So remember that I say that we need to provide the name of the database class. We also provide that the superclass of this particular specific database class is the room database, and it must be an abstract class. So when we click OK, it will create that particular specific class for us. So that is public abstract class demo, which extends the room database, and we need to annotate that particular specific class with the add date of database. And as we have three entities, student.class, course.class and enrollment.class, so we are saying that entities is equal to, and because we have more than one entities, we are putting them in the curly braces, and inside the curly braces we are giving the name of the class that is actually has been annotated as add date of entity dot class and comma separated list of entities. The second parameter or second setting for the add date of database annotation is the version. It means, and that is the version number 1, which is the first version of this particular specific database. Later on, if we change, due to some reasons we want to add new tables inside that data model, maybe we want to change some column information, or we want to add more columns information. If you look at that in the student, we don't have the address, so maybe later on we want to add the address in that student's table. So then we need to change that particular version number from 1 to 2 or 3 or 4 and 5, whichever version it is. So accordingly we can have changed that particular version number. And then export schema is equal to all. It means that all the database, they have the schema, the information is about the tables, about the database. So that is the schema information. If the schema information is equal to true, then you have to set where you want to save that particular schema information in a specific directory location. Right now we are keeping it false, so we don't want to remember those things, so we don't want to export that schema. So that is the third part over here. By default it is true. It means that you need to provide that location, and then it becomes, so we want to keep it simple, so export schema is equal to false. And then we have the public abstract class with class name, that is a demo database, which is the subclass or the child class of the room database. And if inside, if you look at that, we have a private static demo database. So we have the same, the database class that we have defined as an abstract, we are creating a static object of that particular specific class, and we are assigning it a null value, the default value. And then we have a public abstract demo DAO, get demo DAO. We are defining an abstract method which will return me a DAO object of our demo database, and we are defining the method name get demo DAO without zero, without any parameter, or the zero parameter. So this is the method which is a abstract method which is automatically implemented by the Room compiler or the Room framework, and we don't need to implement. So that's why we are putting it in abstract, that will be implemented by our Room framework. And this, because it has an abstract method inside it, so that's why we are defining that class also an abstract class. And the other thing that we are defining a public static demo database get db instance. Get db instance is the name of the method, and it is going to return me the object which has been here, demo database. Okay, it is going to return me that particular specific object of this database. So it takes the final context, it takes the context of the application as an input, as a parameter. Inside that particular database, we are checking this thing. Number one thing, if that demo database, if the database that we have defined here in this class is null, it means this particular database has not been created before, then we are going to create that particular database. If it is not the case, we are not going to database again. We only return this particular private static field back to the caller. So if that particular database is null, what we are going to, we are saying that this variable that we have defined of the demo database type is equal to room. Inside the room library, we have the database builder method that we have defined, we talked about earlier. Database builder, it means it will take three parameters. The first parameter is the context. So we have the context as a parameter of to this method. So from that particular specific context, we are getting the application context. So that is the first parameter for our database builder, room database builder. And then we say that demo database.class, we are providing, look, this is the public abstract class demo database. So we are providing the demo database, the name of the class dot class. So we are providing where we have defined all the settings of our database. At the rate of database, entities are the course, student, and the enrollment classes. Version number is 1, export schema is false. So we have defined those specific what you can say that specific settings of our database. So we need to provide that class name here. And the third parameter is that we are providing the name demo db 19s2. So we are demo db, it's a demo of the database 2019 semester 2. So we are, I mean, you can select whatever name you, mydb1, mydb2, whatever you want. Dot allow main thread queries. By default, whenever we are trying to access the database, we have the activities. Activity is the main thread in which your user interface is running. All the interactions has been going on. By default, I think starting from the version 4.3 or 4.7 of the Android, I can't remember it exactly now, but starting from that specific version number 21, 20, something like that's the end SDK version number 20 or 19, I think 19 something. So after that, they said no, you cannot run those database operations inside the activity class. So if you don't provide this particular dot allow main thread queries, then if you try, I will show you the example. If you try to create run those database operations within our main activity or in any other activity, it will give you an error message. Okay, so if you don't allow, yes, it is a by default, but to make our things simpler, I'm saying that dot allow main thread queries. It means we can run those database operations within our activities classes, activity code. And then we are using a dot build. We are setting a specific property for our database operations, and then later on we are saying that build that particular specific of database. So what will happen? It will take the student dot class definition. It will look into all those definition at the rate of entity indices, at the rate of column information, at the rate of primary key, what are the names of those columns and what are the name of the table. It will create that particular specific table. It will apply all those constraints, at the rate of primary constraints, at the rate of unique constraint, all those indices. It will create that particular specific table. Similar thing for the course and the enrollment. So it will create these. It will create first a demo db19s2 database. Inside that database, it will create that particular student table, courses table, and enrollments table with all the definition that we have given in these classes. So it will create that particular specific database, and it will assign that database object to this demo database variable which we are defining in this particular specific class. And at the then end of this particular specific method, that is a get db instance method, it will return that particular specific database object to the calling. And normally we are using that particular specific object. We are creating that particular database inside our one of our activity mail. We consider the main activity or maybe some other activity depending on your design of your application. So this is what we are saying. We are defining a public static demo DAO. We are defining that particular specific DAO object, and then we are assigning that particular DAO object by student database. Because it's an abstract class, we cannot, or we can say that demo d database. If we look at that, we have this demo database. So if we have that particular specific demo database, so demo database dot get instance or get db instance. If we look at that, I mean, we are saying that demo database, the name of the class, dot get db instance, and then providing the context. So get db instance, and then we say that main activity dot this, we are providing that context. And once this particular specific method is going to return me the database object. And if we look at the database object, inside that database we have this particular specific get demo DAO method. From that particular database demo database object, we are calling this get demo DAO method, which has been implemented by the Room compiler or the Room framework for us. That is going to return us the demo DAO object. So dot student DAO or dot get demo DAO. I think I should change that particular specific line so that it will exactly match with the other rest of the code. And then later on, once we have initialized that data access object, we can use that particular data access object to run any method within that particular specific uh, the the access method that we have defined inside our DAO object. We can access any database. If we have not defined this dot allow main thread queries, then we cannot run those methods within our activity class. Remember this thing. So let me stop at this time and change these particular specific values which exactly match to the rest of the code, so then it will make much more, it will make more easier to understand. So I have changed that particular code so that it will become more understandable. If we look at our uh, class, so we have a demo database class in which we have a get db instance method. So what we are trying to do here, so we are initializing a data access object demo database dot get db instance. We are providing the context, that is the current activity, this, and dot get demo DAO. So the first part up to this particular specific point, demo database dot get db instance, this, it will create the database and it will return me that particular specific database object. And using inside that database object, we have the get demo DAO method, which is an abstract method which has been defined in this class, which has been implemented by the Room framework, and it will return me the DAO the interface object. That is we are initializing in this particular variable. That's a public static demo DAO object. And using that particular specific DAO object, we can call any method which we have defined in this data access object. So in this way, we can insert, we can update, we can delete, we can read, we can query, we can do all those database operations. And as I explained you earlier, that allow main thread queries, it means that we can simply write this particular specific code within the class of that particular specific activity. Any activity we can write and it will work perfectly fine. So this is our theoretical part of that room architecture, and in the next video I will show you how we can actually create all those things within our the Android Studio and how it is going to work for us. Thank you.